right, so today we're going to start this packet talking about topic 6.3, and this is a really important lesson, getting ready to do what we're about to do because it introduces the definite integral as the area of a region. And now I've mentioned integral a little bit when we've been doing these area problems, but today is the first day where we're actually going to see the notation and talk about it a little bit more. So if f is a continuous and non-negative on the interval from A to B, then the area of the region bounded by the graph of f, which is, and the x-axis and vertical lines at x equals A and x equals B is given by this notation. And so let's talk about what these things are. So this symbol right here means the integral. So that's the integral sign. All right. And then this A down here at the bottom is called the lower limit. All right, and then B, we can squeeze it, is called the upper limit. Okay, f of x is the integrand. All right. X is the variable of integration. And then you would read this whole thing as the integral of f from A to B. All right, and I want to show you what that means graphically. Now it does say that f is non-negative, so this graph of f is going to be above the x-axis everywhere. So I'm just going to, or is above the x-axis from A to B. So outside of A and B, we can't go below. Let's try that again. So that's F. All right, and then let's say A is here and B is here. So what that integral represents is it says the area of the region bounded by the graph of f, the x-axis, and vertical lines at A and B. All right, so the area in this region is what we're looking for. That's what that integral will give. All right, so then for the next two, we are going to shade the area you would find for the given definite integrals. So I have the graph of x squared plus 1, and it's not perfectly square, but that's okay. And we want the integral from -2 to 4 of that function. And so -2 would be right here. and 4 is here. Now, I didn't label this on your paper, but the y's are actually going up by 5. So that's not super important, but you know that looks more spread out than the function normally does, the x squared function. All right, so what I would do is I would draw a vertical line at x equals -2 and x equals 4. And then I would shade the region between the x-axis, that function, and between those vertical lines. Okay. So you guys try this last one on your own, please. Okay, so there's really not a vertical line to draw at 0 because it actually goes through 0, 0. All right, so that's the area that we would be finding if we found that integral. All right, so we're going to be talking in this packet about a lot of the things we've already talked about. The difference is now we understand the integral notation, and so we can look at it a little differently, but still using the same methods. All right, so as a reminder, there are 4 methods by which you can approximate a definite integral: the right Riemann sum, left Riemann sum, midpoint Riemann sum, and trapezoidal sum. So this activity, this first one, we're going to focus on right and left. And so since this is a distance learning day, we can't really do the partners, so you're kind of on your own, or I'll just lead you through it. So what we're going to do is we're going to determine if this approximation method in the table has been using right or left Riemann sums. So first, we are finding the area between -2 and 3, or the integral between -2 and 3. So that between those two. And we have 2 rectangles. All right, and then one of the rectangles, the base times height is 5 times 2. And the other rectangle, the base times height is 2 times 3. Now we're using the dots in the problem. So this 5 is going to come from that 5. So that's definitely the height. All right, of one of them. And then the 2, this 2 right here, should probably be this width, and it is. So that rectangle would be this one. I drew it a little bit wide. Okay, and then for the other problem, this 2 is this height, and this 3 should be this width, and it is. Okay, then we have to figure out if that's right or left. So looking at the way we've drawn the rectangles, the right corner of the rectangle is sitting on the curve, so that's going to be right. Okay, now I'm going to erase this. You guys might just want to use a different color pencil or something, but we kind of have to write on top of what we just did, so it's not super easy.